Welcome back to Data Sciency. Imagine a world where AI can adapt to anything, much like how we adjust when we learn something new, just like the octopus that changes its color to blend in, or how our brains rewire themselves after injury. So AI could do the same. Today, we're diving deep into Transformer-squared, an AI system that can adapt in real time to new tasks. Stick around because what we're about to explore is set to change the way AI interacts with the world. Let's start with something we all know: nature's ability to adapt. Adaptability is key to survival. Think about how an octopus changes its skin color to blend with its surroundings, or how our brains adjust after an injury. Our ability to adapt allows us to thrive no matter how challenging the environment. But what if AI could do the same? What if it could adjust itself based on the task at hand without needing to be reprogrammed? That's the dream. And Transformer Square is one step closer to making that a reality. Just like living organisms, AI could change to meet the challenges it faces, learning and evolving over time. Before we dive into Transformer Square, let's understand how AI, specifically the large language models LLMs, work. So, these models are like brains that store knowledge and process information through what's called weight matrices. Think of these matrices as the neural pathways of the AI. They store everything the model has learned during training, whether it's language understanding, math, or coding. So these pathways, however, are static. They don't change unless we retrain the whole system. So this is where the challenge lies. Static models struggles to adapt to new or unseen tasks. So they can think on their feet and they definitely can learn on the fly. So here comes Transformer Square model that changes all of that. Unlike traditional AI models, Transformer Square is designed to adapt in real time. Instead of being the rigid and static system, this system can dynamically adjust how it processes information based on the task it's faced with. So how does this work actually? So, Transformer Square actually uses a two-step process. First, it analyzes the task, that what type of task is it, to understand the need of it. Then it adapts its brain to fit the task, adjusting the way it processes information to generate the best possible result. So this is done by modifying the weight matrices, the brain of the model. So breaking down the brain of an AI model, now let's talk about how Transformer Square breaks down its brain. So just like how our brains has different regions that specialize in certain tasks like language, memory, vision. So the AI model has components within its weight matrices that specialize in different type of tasks. So these could be math, language understanding, coding, or even visual reasoning. So to help the AI adapt, Transformer Square uses a technique called singular value decomposition, SVD. So think of SVD as the surgeon who slices up the brain of the AI, identifying which part are responsible for what task. So this helps Transformer Square focus on what it needs to be done to improve or adjust for any given task. So it can enhance the certain components and suppress others, making the model more effective and efficient. But there's a question that how does Transformer Square learn to adjust these components? Well, during training, what it does, it uses something called singular value fine tuning, SVF. Now, this model helps Transformer Square figure out the right balance between the different component of its brain for specific tasks. For example, imagine the model that needs to solve a math problem, and the training system might tune the math related components to work harder, while the language components take a backseat, means those language components will be suppressed. So Transformer Square also learns this through reinforcement learning, adjusting its z vectors. Means these are small representations that help it decide which components to amplify to like enhance or which to suppress for any given task. So these Z vectors are like dials on a radio. For math, the model turns up the volume on the math components. For language tasks, it adjusts the dials to focus on the language components. And the beauty is that it does not require retraining the whole model, just minor tweaks for each task. Now, once Transformer Square is trained, it's ready to tackle any task in real time. Now, this is where the magic happens. Now, when you give Transformer Square a new task, whether it's solving a math problem, answering questions, or analyzing data, it instantly adjusts how it thinks. Now, there are three main ways that it adapts to tasks. So, the first one is prompt-based adaptation. So, this model, it looks at the input prompt and selects the right Z vector, so in which it adjusts the approach accordingly. And the second is classifier based adaptation. So this model, what happens in that the model uses a classifier to identify the task and then adjust itself. And then the third is few shot adaptation. Here what it happens. Now if the task is new, the transformer square learns on the fly, in which it will adjust its z vectors based on a few examples. These methods ensure that transformer square can handle a wide variety of tasks, all while being super efficient. So, how does transformer square stack up against traditional methods? So, the test was given to it across a variety of tasks including math like GSM 8K and math, coding challenges, reasoning, in which there was ARC Easy, ARC Challenge, and even visual questions like text VQA and OKVQA. So here you can see the results of it in GSM 8K, in which the SPF was 79.15. In MBPP Pro, it was 66.67, and in ARC Easy, the score was 89.56. Here you can see how the score of it is. So it's like better performing than the other models. And then it was evaluated on more of the methods also such as math, human eval, and art challenge, in which it got the score of 25.47, 62.99, 82.61. Here also in the transformer square few shot, it got 13.39, 47.40, and also here also in transformer square in prompt. So here in human eval, the transformer square in prompt, it got the score of 79.88, and in arc talent it got the score of 88.48. So in most of the tasks it got the better score than the other models. And here also in math you can see in SPF and in SCF in the order, the shuffle, and the future adaptation. In Art Channel and Human Challenge, it was the first rank. And one more cool feature of Transformer Square. So it can share its learning between different AI models. So this was tested by transferring the Z vectors from one model to another. So what does this all mean for the future of AI with Transformer Square? So we're looking at the world where AI is no longer static. These systems could learn and adapt continuously, just like living organisms. So imagine an AI that can adjust to new situations, learn from experience, and evolve over time without needing a complete reboot. And that's a wrap on Transformer Square. We have explored how it adapts in real time, outperforms traditional models, and even shares knowledge between AI systems. So this is just the beginning, and the future of AI looks incredibly exciting. If you have found this breakdown helpful, don't forget to hit the like button, subscribe to Data Science, and ring the bell for more AI updates. Until next time, stay curious, stay innovative, and keep exploring the world of AI. Bye bye.